everyone, I'm Patricia, and today we will be dealing with the distance of a point to a line and the distance between parallel lines. But we'll first deal with the distance of a point to a line. So here, you have a point and a line. And when looking for the distance between these two, we are actually referring to the shortest distance from a point to a line, and it is a perpendicular line segment. So this line segment right here is actually the perpendicular distance between these two. Sure, you can measure the distance of a point to a line diagonally or in any way you want, but that is not the shortest distance. And today we will be showing you two different ways or approaches on how to solve for the distance. And first, we will be using a formula, and that part will be elaborated and explained by Miss Fiel Namenzo.
Hi, this is Fiel, and we will solve for the distance of a point to a line using a formula. The formula is distance equals the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. Before starting, if you're given an equation that shows slope-intercept form, make sure to rewrite it to a general form of the equation. And also, the absolute value of any number is always positive. Now, for example number 1, find the distance from the point 4, 5 to the graph of 3x minus 4y plus 18 equals 0. For instance, we have our graph here. We have our line in the form of ax plus by plus c equals 0. And we have our point here, x, y. Now, we have to find the parallel or the shortest distance between the point and the line. In order to get that, we need to use the formula d equals the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. But before plugging our values, let us first identify which is which. For our point, we have the coordinates 4, 5, and our formula 3x minus 4y plus 18 equals 0. Since the given line is in standard form, it's easy for us to identify the a, b, and c. A is equal to 3, b is equal to negative 4, and c is equal to 18. x1 is 4 and y1 is 5. It is important to first identify the given so you plug the values correctly. So this will become d is equal to the absolute of 3 times 4 plus negative 4 times 5 plus 18 divided by the square root of 3 squared plus negative 4 squared. So we have 3 times 4, which is 12. Negative 4 times 5 is negative 20. Copy 18. Then 3 squared is 9. Negative 4 squared is 16. Now 12 minus 20 is negative 8. And 9 plus 16 is 25. Negative 8 plus 18 is 10. And the square root of 25 is 5. So if we divide 10 by 5, we'll get 2. And that's the distance between the given point and the line. Example number 2. Find the distance between the point 5, 1 and the line y equals 3x plus 1. In the graph, you can see a line in the form of ax plus by plus c equals 0 and the point here x, y. To find the distance, use the formula d equals the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared, where the point is 5, 1 and the line is y equals 3x plus 1. We first need to express the given line in standard form to distinguish a, b, and c. Subtract 3x and 1 from both sides, and that would be y minus 3x minus 1 equals 0. Now we see that a is 3, b is negative 1, c is 1, x1 is 5, and y1 is 1. Now let's start plugging in. Using the formula for the distance from a point to a line, we have d is equal to the absolute value of 3 times 5 plus negative 1 times 1 plus 1 divided by the square root of 3 squared plus negative 1 squared. 3 times 5 is 15, negative 1 times 1 is negative 1, copy 1. Then 3 squared is 9, and negative 1 squared is 1. We can expand the expression if we multiply the fraction by the square root of 10 over square root of 10. Then multiply the fractions. We have to multiply the numerators and denominators separately. Now we have 15 square root of 10 over 10. Reduce the fraction by 5. So the distance is 3 square root of 10 over 2. The next given is how far apart are the line y equals half x minus 3 and the point 2, 7. This is the graph of the given, and we're still using the formula to find the distance between the point and the line. We have the point 2, 7 and the line y equals half x minus 3. First, we'll rewrite the equation y equals half minus 3 in this form to identify a, b, and c. Subtract half x and add 3 to both sides. Multiply both sides by 2. So it will be 2y minus x plus 6 equals 0. Now we see that a is negative 1, b is 2, c is 6. Plugging this with x1 is 2 and y1 is 7 in the formula. So d is equal to the absolute value of negative 1 times 2 plus 2 times 7 plus 6 divided by the square root of negative 1 squared plus 2 squared. So we have negative times 1 times 2 is negative 2. 2 times 7 is 14. Copy 6. Then negative 1 squared is 1. And 2 squared is 4. After calculating the sum or difference, we have 18. And since any root of 1 is equal to 1, it will be 1 plus 4. Add the numbers. Now, we have the distance, which is 18 over 5. That's all! I hope you learned something about the distance of a point to a line using a formula. And in the next video, let's try to find out how to solve for the distance without using the formula. Thank you!
Hello, it's Patricia. I'm back again, and in this part of the video, I'll be showing you the different approach on how to solve for the distance between the distance of a point to a line. And today, and this part, I will be using the formula that was introduced to you earlier. So now, let's read our given. Find the distance between the point 5, 5 and the line y equals 2x plus 5. So just a reminder, if you are given a line equation in standard form or general form, you have to rewrite it into slope-intercept form. So here in our graph, this is our line, this yellow thin line right here in the equation y equals 2x plus 5, and our point with x and y coordinates 5, 5. And this black line right here, this black line segment right here, is our perpendicular distance. And we need to find the distance. We need to find the distance of a point to a line. And what we want to do here, since we already have our x and y coordinates, our lines, x and y coordinates, we need to find the x and y coordinates of the point of intersection, this one, the point of intersection of the perpendicular line segment and our line. Because we will need that the x and y coordinates of this point and this point will be used later for solving the distance of a point to a line. So the very first thing that we need to do is to find or identify the slope of our perpendicular line segment. We need to find the slope right here, and we need to get the opposite reciprocal of our slope. So if you remember from, if you remember the slope-intercept form from your previous grade, this 2 right here is our slope. It has a hidden 1 denominator. And this 5 right here is our y-intercept. That is the y-intercept of our line. And in order to get the opposite reciprocal, what you need to do is just to get the reciprocal of our slope, which is 1/2, and get the opposite sign. Since this is a positive 2, we need to get the opposite sign, which is negative. So the slope of our perpendicular line segment is -1/2. Then the next thing that you need to do is to get the equation of our line segment. So we need to get the equation of this line right here. And in order to do that, we will need to get the point slope form. We will use the point slope form. And the point slope form is in the form y minus y sub 1 equals m multiplied by the quantity of x minus x sub 1. And we have here our values, this 5, 5, and this -1/2. And we just need to plug it in our point slope form. So we start plugging the values. We have y minus y sub 1. Our y sub 1 right here is 5. So we put 5 right here. Equals m, our slope, this is our slope, and we need to plug -1/2 multiplied by the quantity of x minus 5, since our x sub 1 is 5. Then perform the indicated operations. Multiply -1/2 by x. This will become -1/2 x. Multiply -1/2 by -5, and that will be equal to +5 over 2, or 5/2. Then this -5 right here, you can combine this with 5/2. So you transfer this one right here. It then becomes y equals -1/2 plus 5/2. Okay, let me just do it again. Y equals -1/2 x plus 5/2 plus 5. Since when you transfer -5 and when you transfer it here, the signs will change. It then will come to +5. Then combine these like numbers. It will then become, and it will result to y equals -1/2 x plus 15 over 2. So, excuse me. So that will be our equation. This will be our perpendicular, the equation of our perpendicular line segment. Then the next thing that you need to do is to get the x and y coordinates, and we will use the the equation of our line equation, and the equation of our line segment in order to get the x and y coordinates of our point of intersection. So it will then become like this: 2x plus 5 equals -1/2 x plus 15/2. And because we have denominators right here, it will be easier to get rid of it. So you will multiply both equations, this equation and this equation, by 2. It will then become 4x plus 10 equals -x plus 15. Because when you multiply 2x by 2, it will become 4x. 5 times 2, 10 equals -1/2 x. Oh, I'm sorry. -1/2 multiplied by 2 is equal to -2 over 2, which is equal to -1, so we have -x. Then 15/2 multiplied by 2 is equal to 30 over 2, and when you simplify it, it's 15, positive 15. Then you combine the like terms. You will transfer x over here, so that will become 4x plus x equals 15 minus 10, because you will transfer 10 right here. Then perform the operations. 4x plus x is equal to 5x, and 15 minus 10 is equal to 5. And because we just want x to remain, so we will divide both sides by 5. So it then will become x equals 1. So our x coordinate for this point is 1. And we still need to get the y coordinates. And in order to do that, we will just need to use the line equation right here and just plug our known values. This value, this x value, we'll plug it in here. So this will become y equals 2 times 1 plus 5. Then 2 times 1 is equal to 2 plus 5. 2 plus 5 is 7. So our y coordinate is 7. Then now we have our x and y coordinates. We have our coordinates for this point and this point. Then we will proceed into using the distance formula. So the distance formula is square root of x sub 2 minus x sub 1 squared plus 9 plus y sub 2 minus y sub 1 squared. Then plug the known values. We plug it in here. X sub 2 is 5. X sub 1 is 1. Then y sub 2 is 5. And y sub 1 is 7. Then square root of. Don't forget the square root. Don't forget the radical sign. 5 minus 1, 4 squared, plus 5 minus 7 is equal to negative 2 squared. Then 4 squared, 4 times 4 is equal to 16. Negative 2 squared, negative 2 multiplied by itself is positive 4. Then you add this up. 16 plus 4 is equal to 20. Then the square root of 20. Again, don't forget the radical sign. Don't forget for the radical sign. Okay, so 4 times 5 is not yet the answer. These are multiples of 20, and 4 is a perfect square. So we're going to use 4 times 5. Then the square root of 4 is 2, and 5 isn't a perfect square. So this will stay under the radical sign. So our distance, the distance of a point to a line is 2 square root of 5 units. I hope you learned something from it, and in this part, Ms. Hanyola and Ms. Rama will show you the ways on how to solve for the distance between parallel lines. Thank you.
Greetings everyone. In this part of the video, we will tackle about the distance between parallel lines. Parallel lines are lines that has the same distance apart. I am talking about the shortest perpendicular distance between parallel lines. Take these as a reminder that we won't be dealing with intersecting and perpendicular lines because these lines already intersect at a point, and to find for its distance is of no avail. We will be showing you two different ways on how to solve for the distance between parallel lines. You can use a formula to solve for it, but you can also solve for the distance without it. Now, let's find out on how to find for the distance using a formula.
Good day everyone, this is Donable Rama from grade 10 Diamond. Find the distance between the parallel line of 5x minus 12y is equal to 12 and 5x minus 12y is equal to 38. Each of them is in form of ax plus by is equal to c. A represents the coefficient of x, while b represents the coefficient of y, and c represents the constant term. A in the first equation is 5, and A in the second equation is also 5. B in the first equation is negative 12, and B in the second equation is also negative 12. C in the first equation is 12, and C in the second equation is 38. Since the 12 is different from 38, let us say this is C sub 1, and this is C sub 2. If you're going to graph these two equations, their graph will look like this. This is the y-axis and this is the x-axis. Since we're talking about parallel line, it must look like this because parallel line will never intersect. And if a line will intersect, that is not a parallel line because it is an intersecting line. Now let us solve for the distance between the two parallel lines. To solve for the distance, we're going to use the formula, which is d is equal to the absolute value of system 2 minus c sub 1 over the square root of a squared plus b squared. Just substitute the value of c sub 2, which is 38, minus the c sub 1, which is 12, divided by the square root of a, which is 5 square, plus negative 12 square. So 38 minus 12 is equal to 26, all over square root of 5 square, which is 25, plus the square root of negative 12, which is 144. So the absolute value of 26 is 26. And then 25 plus 144 is equal to 169. Just copy 26, so the square root of 169 is 13 because 13 times 13 is equal to 169. Let's simplify 26 over 13. 26 over 13 divided by 13 is equal to 2 over 1 or just 2. Therefore, the distance of the two parallel line is 2 units. Find the distance between the parallel line of 2x minus 3y is equal to 12 and 2x minus 3y is equal to 21. Each of them is in form of ax plus by is equal to c. A in the first equation is 2 and a in the second equation is also 2. B in the first equation is negative 3 and b in the second equation is also negative 3. C in the first equation is 12 and c in the second equation is 21. Since the 12 is different from 21, let us say this is c sub 1 and this is c sub 2. If you are going to graph these two equations, their graph will look like this. This is the y-axis and this is the x-axis. Again, parallel line must look like this. Now, let's solve for the distance between the two parallel lines. To solve for the distance, we're going to use the formula, which is d is equal to the absolute value of system 2 minus c sub 1 over the square root of a squared plus b squared. Just substitute the value of c sub 2, which is 21, minus the c sub 1, which is 12, divided by the square root of a, which is 2 square, plus negative 3 square. So 21 minus 12 is equal to 9. All over the square root of 2 square, which is 4, plus the square root of negative 3, which is 9. So the absolute value of 9 is 9. And then 4 plus 9 is equal to 13. It must be rational denominator. So our answer is 9 square root of 13 over 13. Therefore, the distance of the two parallel lines is 9 square root of 13 over 13 units. You need to put some units because we're dealing about distance.
That is how you solve for the distance using the formula. Since there are two approaches on how to solve for the distance between parallel lines, now let us try to find out on how to solve for the distance without using the formula.
Hello, it's Feya again. Now, we are going to solve for the distance without using the formula. So, I have here a sample problem. We need to find the distance of this one and this one. So, we have here the equation of the first line, which is y equals 3x plus 2. While the equation of the second line is y equals 3x minus 5. What we need to do is to get the coordinate of the points so that we can use the distance formula. This one here is the shortest distance between these parallel lines. We can use the equation y equals 3x plus 2. 3x is the slope and 2 is the y-intercept. The coordinate of the first line is 0 and 2. The next step is to identify the slope of the perpendicular line segment. So to get the slope, just get the reciprocal of 3. The reciprocal of 3 is negative 1/3. Why negative 1/3? Because underneath 3, there is a hidden 1. So we have now the y-intercept and our slope. The next step is to substitute the y-intercept and the slope to the formula y equals mx plus b. Now we will substitute. So y equals our m is negative 1/3 x plus b, our y-intercept is 2. So it is y equals negative 1/3 x plus 2. So the next thing that we will do is to find the x and y of this point. To get the coordinates, we will use the second equation, which is y equals 3x minus 5, and the equation of our line segment, which is y equals negative 1/3 x plus 2. So it is now negative 1/3 x plus 2 equals 3x minus 5. As you can see, the equation has a fraction number, and we all know that it is hard to plot in the graph if there is a fraction number. So what will we do? We will multiply both equations by 3. So it will be like this. After that, we will distribute. So 3 times negative 1/3 x is negative x. 3 times 2 is 6. And the other equation, 3x times 3 is 9x. 3 times negative 5 is negative 15. Next step, we will combine like terms. It will become 15 plus 6 equals 9x plus x. So 15 plus 6 is 21, and 9x plus x is 10x. To cancel 10, divide both sides by 10. Cancel 10, 21 divided by 10 is 2.1. Therefore, x is equals to 2.1. Now that we already have our x, we will now solve for y. To solve for y, we will still use the same equation, which is y equals 3x minus 5. We already have the value of x, so we just need to substitute. So it will be y equals 3 times 2.1 minus 5. Then multiply. 3 times 2.1 is 6.3 minus 5. 6.3 minus 5 equals 1.3. So now we have the coordinates of both lines 0, 2 and 2.1, 1.3. We will now solve for the distance of the parallel lines. The formula is distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. Next step is to substitute. So d equals square root of 2.1 minus 0 squared plus 1.3 minus 2 squared. Next step, perform the operations. 2.10 is 2.1. 2.1 squared is 4.41. 1.3 minus 2 is negative 0.7 and squared 0.49. Next, multiply 4.41 to 0.49. That is square root of 4.9. And square root of 4.9 is 2.21. Therefore, the distance of the parallel lines is 2.21 units.
We hope you learned something from the tutorial video. Thank you for watching.